Hey there, it's Jason from Codemanship with a video diary all about object-oriented programming. So I've been sort of spurred on by a couple of things that have happened over the last year or so. First of all, I tweeted a question quite some time back now, just innocently asking, is it kickball or is it ball.kick? And there were a lot of people who had a preference for the former, kickball. A few had a preference for this. But there seemed to be a kind of a fundamental misunderstanding of what we mean by object-oriented programming, because in actual fact, these two lines of code mean exactly the same thing. They mean exactly the same thing. A lot of people think that this is more intuitive because this is the way round that we would say it or write it in English. We kick the ball. The ball is the object, you see. Now, what most OO languages, the ones that use the dot notation, for example, do is they flip that around and they put the object in front. And remember, it is the object. It is not the ball kicking. It is the ball being kicked. The ball is the object, hence object-oriented programming. And what a lot of people sort of mistakenly believe is that in object-oriented programming, we conceptually view the objects as doing the work, and they'll say, well, a ball doesn't kick itself. Well, here's the thing. In OO programming, it kind of does. And I wanted to illustrate that with a simple example, but also to tackle another question. So someone posted a comment about one of my Codecraft videos where I used a CD warehouse example, and the test I was working on was buying a CD. And the effect of buying a CD, or one of the effects of buying a CD, is that the stock of that CD goes down in our warehouse. And they sort of asked, why is stock a property of the CD? Well, I think it should be a property of the catalog. So I want to talk a little bit about how I approach object-oriented design. And I'm going to do it with a little example. And that hopefully will bring us back to the whole kickball, ball.kick kind of conversation. So here's some code that, a test for code that calculates the price of a fitted carpet. I've annotated in this test, I wouldn't normally do this in real production tests, but just for illustration, I've annotated which part of this test is the code that actually does the work. So I'm doing this in the kind of test-driven development as if you really mean it style, that workshop designed by Keith Braithwaite, where we actually write the code to pass the test inside the test. So we don't declare classes or methods or anything like that. We just say, okay, well, let's just write the code that does the work. So here's some code that calculates, based on these three inputs, the width and length of the carpet and the price per square meter. It calculates the price using that information. Now, this code doesn't really belong here. It does the work, but it's not exactly reusable where it is. So let's start to extract this. Let's start to modularize and see what happens. So the first thing I'm going to do is I'm going to extract a method. GetPrice seems like a reasonable name for it. Let's make it sound more like an action though. Calculate price. Let's put a better verb in there. Okay. And obviously, I immediately retest, even though this is just a demonstration. I will always retest because I know what happens when I don't. Okay, now let's take a look at this new method. Let's get rid of my Maven tab so you can see it more clearly. Let's take a look at this calculate price method. So this is the method that does the work, and this is where I always start in the design process. What work needs to be done? This is now the method that does the work. The next question is, what data does it require? Well, it requires this data. Now, I'm very much in the habit of encapsulating work and data together, and I think this is where a lot of confusion comes from, and it's also related to the ball-kick, the ball.kick stroke versus sort of kick-ball argument. So these are three pieces of data that are required to do this work. If I wanted this to be in its own module, which I do, I don't want it to be in the tests. What I could do is, first of all, just introduce an object that has those as fields. So let's introduce a parameter object. And let's call that fitted carpet. Seems like a reason. So I would choose a name for it. Now remember, I am just choosing a name. The most important thing is what work does it do? But now I'm looking for a name for this thing, and normally I would look for the name of the thing to which I think this action is being applied, the thing that knows these things, the ball that's being kicked, if you like. And there we see that it has to have these fields, and it'll create a constructor. So it's going to create getters and so on and so forth. And we probably want to put that. Well, we'll leave it in the test folder for now. We can move it later. Let's do one refactoring at a time. Okay. There we go. Now, look at the code we've got now inside this method. This is the equivalent of kick ball. This is the equivalent of this. We've got a method that acts on an object. And when you have a method that acts on an object, look what you get. It's called feature envy. It's a code smell. It's when a method of one class has envy for the features of another class, giving a strong indication that that method is in the wrong place. I want to encapsulate this work so that the client doesn't know how the work is being done, and ideally doesn't know what data is involved. So I'd like these getters to go. So what I'm going to do is I'm going to move calculate price to the object of its feature envy. There's a very useful word. But before I do that, I just want to make a point about this first parameter here. So if we go back to the days when C ruled the world, particularly in the late 80s, as object-oriented programming languages became more popular, so for example, when I started working in C++, I became very much attached to objects and that ability to encapsulate. I was a big fan. But occasionally I would do some work on a platform for which there was only one compiler, and it was a C compiler. So we would try and follow a convention that as much as possible made our C code appear to be object-oriented. We wanted to try and get the benefits of object orientation in C, which you can totally do, because it has everything you need, pointers and data structures and so on. So we would follow a convention where we would have a module that contained all of the functions that apply to a particularly user-defined data structure, like, let's imagine fitted carpet. Well, technically it is. It's a data structure. Let's take a look at it. Where are you, my little friend? It's a data structure. At the moment, it's just a bunch of fields and getters. So think of that as being like a C data structure. And then what we would do is we would pass an instance of that data structure in always as the first parameter of each of those functions. So we're saying do this to this object. And that word this is very, very important, because that essentially is our this pointer. There's no magic to OO programming. That first parameter is the magic hidden this pointer. Now, what we do in OO programming is we flip it around. Syntactically, the language has a syntax that says take that this pointer and put it in front of the action. So rather than going action object, do this to this, we have object action to this, do this. The ball is the thing being kicked, the thing to which the action is being applied. And that's how you should read it. So let's go back to our test code here. So this method here has feature envy, and it has feature envy because we're passing our fitted carpet in as the first parameter. It's kind of the this pointer, if you like. And we want to get it all in its own module. So what I'm going to do is I'm going to move this to that object, this instance method. Let's do that now. Okay, and I rerun my tests. Look at that, isn't that great? Still works. I do love IntelliJ. Right, could not live without my automated refactorings. Okay, now that we take a look at this, fitted carpet test now just tells the carpet to calculate the price. So let's make that more explicit now. Let's introduce a local variable just so we can read it. And let's call that, I can just call it carpet if you like. So now it's not calculate price for carpet, it's carpet.calculate price. But they mean, as you can see, by the fact that the tests are still passing, they mean exactly the same thing. It's just a different way of saying it. But because we've done it this way, and this is one of the main advantages of working in this style, we no longer need these getters. So let's inline them all. Let's get rid of them all. I'll do them in one go because it's a fairly small and safe refactoring. There we go. So you can see now that the data is encapsulated inside. Fitted carpet knows what it needs to know in order to do this work. And our client doesn't need to know. Now, of course, there are other design principles we'd need to think about. For example, if I was writing real code, real production code outside of a test, then I wouldn't want the object actually creating, instantiating the fitted carpet to use it. So whoever's calling calculate price won't know that the constructor looks like this. So it won't know that it has a width and a length and a price per square meter. All it knows is that it can tell it to calculate a price. Tell, don't ask. That's what we mean by tell, don't ask. So rather than having a function that asks for the data from a fitted carpet, from a data structure or a data object, in order to do that work, it tells the object that has the data to do that work. And since that is good design, I tend to drive the design process in that direction. So I start with the work, and that's very important. I always start with what work needs to happen. And then I work my way backwards from that, often by refactoring, or certainly by examining the data involved in doing the work, either in code or on paper, and asking myself, okay, therefore, what module or what object do I need that encapsulates that data as well as doing the work? And then what would be a good name for that thing? So I'll look at the customer's requirements and go, well, as they describe that action, what looks like the object in terms of the way they've described it. Now, in my CD warehouse, when it comes to buying a CD, which changes the stock level of that CD, the word that kept coming up was CD. It's the CD's stock that changes. So if I want a class that does the work involved in buying a CD, in other words, changing the stock count of that CD, and encapsulates the data, whoever does that work needs to know what the stock of the CD is, otherwise we break encapsulation. And so when I read cd.buy, I'm reading it that way round. The CD is being bought. What happens to the CD? Its stock level goes down. But it is arbitrary. I chose that name. I could have called it something else. I could have called it CD stock, for example. So that's a very important part of it, is choosing the names for these things so that it kind of makes sense. But I'm only trying to make it sense in the context of doing the work. Always coming back to, it has to pass the tests, has to do the work. And then I think about design in terms of data and encapsulation, and if necessary, polymorphism and all that wonderful stuff afterwards. So that to me is the essence of object-oriented programming. It's the way that you should read the code, such that kick ball and ball.kick mean exactly the same thing, but this is the OO way of saying it, and it's also the OO way of doing it. It allows us to encapsulate work and data in the same module so that the rest of the system, the clients, don't need to know what's going on internally. So it's good design. So that's kind of the subject of today's video diary. Object-oriented programming, object-oriented code, a lot of people are reading it the wrong way round. And you have to remember it is called object-oriented programming for a reason. It's not subject-oriented programming. It's not about an object that does things to other objects. It's about objects doing them, so having things done to them by the computer. So when people say, well, where's the object that does the work? I said, well, there isn't one. There are objects that tell it to do the work, but we kind of, again, it's a language thing. I'll tell you who does the work. The CPU does the work, and it does the work to that object. Under the covers, it does things to memory locations, basically, which we would call objects, things on the heap. So that's the essence of OO programming. That's the essence of OO thinking. And that's how I read OO code. So anyway, that was today's video diary. Probably a good thing that you can't see my face because I haven't been up that long, and I'm a bit of a mess, but there you go. I hope you are well. We in the UK are kind of in a sort of Schrodinger's lockdown, really. There are parts of the UK that are more locked down than others. There are rules in place for the parts that aren't, like London, about, for example, registering when you go to a pub or a restaurant, or wearing masks in shops. And I'm now aware, of course, that all around the world, most countries are in different stages of some kind of lockdown or some kind of restrictions. But wherever you are, whatever you're doing, I hope you are well. There will be more video diaries coming up over the summer and beyond. And also I'm going to make a point. I've had a bit of a staycation, a bit of a week off, but I'm going to make a point next week to carry on with the C# codecraft videos. And I'm going to look to finish those off and then move on to finishing off the what's left after C#. I suppose it's Python, the Python videos. So the goal is to have all those done by sort of mid to late September. So we have the full series for all of them. Just one final plug for the channel. If you're interested in more of the videos coming up, or if you're enjoying these videos, hit the subscribe button or ring the bell for notifications. I'll speak to you again soon.